something changed in revenue for December. Their number changed.
Yeah, I got it right here. I'll do it tomorrow.
Just make sure you do it.
I found that I found out about one. Yeah, I think so.
Is it the screen?
A little bit of both. The tables aren't level, the
That's a very
screen's not level.
That's as high and straight and big as it
A lot of fun.
It is. I'm trying to do multi-trace base, and it's pretty much the same thing. So,
6:38.
So a couple more minutes to give everybody a chance to.
wonderful.
I am purple. I had to take a couple of pictures today. So I figured what better color? It is royal.
How many meetups do you come to?
It counteracts my personality.
This is like my third one.
Oh, really? How many does Brad come? Like, does Brad come
Yeah,
every month?
it comes to almost all of them.
Really?
Yeah.
I just signed up for this one, like the Iron Yard. Yeah. When you sent me that link, yeah.
Yeah, that's why I asked Brad if he was coming, because I was actually a little surprised he wasn't.
Why wasn't he coming? He said he wasn't. I heard him.
Well, this particular meetup is about what he does all day, every day, so I think he felt like he would be.
Did you watch the webcast from
I'd rather own.
last night?
No, I forgot.
I started to. I was listening to it while I was doing while I was working, and I kept looking over, and I'm like, okay, I gotta shut this off.
The second reason why I chose that one.
I couldn't get any work done.
Actually, I have a shirt that is like snake pattern, and I love it where it's nobody's thinking there's an unshot. Set me.
For a long time program, logo. It had a lot of batteries.
That's awesome.
It's very iconic.
That's fun.
Oh, I'm Danielle.
Danielle, nice to meet you. Casey.
Casey.
How much the top?
Okay, this is the first time here, so I'm excited.
Woo! Awesome.
I like your shirt, by the way. It's really cute.
It's very purple.
It is, but I really like it. It's a nice piece.
Being purple isn't a bad thing. It's just, at least it shouldn't be.
I was working not in bad shape. I can't pull off that shit. Like a little lavender.
Oh, hey! The color of data is purple. Or blue, I guess. We'll allow it.
We'll mix it up a little bit.
Whenever you're ready.
Oh, I don't want to stand, but just have to see everyone. We have a little more than 20 people here. That's pretty good.
Woo.
All right, this is Orlando Machine Learning and Data Science.
Hi, everybody.
I'm Michael DuPont. I'm the organizer of Orlando MLDS. This is Casey Face. She is my co-organizer. And
Also morale officer.
also Chief Morale Officer, made official this week. And we noticed that the last meetup, we were focusing on visualizations, and a couple of people were having some trouble getting the data into the programming language to begin with. So we're going to do an overview of a bunch of different data types, data formats, and how to read those into both Python, into pandas in Python, and in R.
Moving forward, we'd love to be able to use this as a repository to point people to kind of get started. So if you have any feedback on that point as well, let us know.
Yes, we want this meetup to be more of a workshop which means we actively encourage everyone to bring in their computers and follow along. We have the code posted in a repository, which I just added as a comment in the meetup page, as well as in the description for our YouTube live stream. So you can get to it that way. And meetup page, we have a channel in ODEV Slack. It is #data-science. The GitHub repo for today, and Orlando MLDS is where you can find all the projects that all the projects and code repositories that people will be posting for this particular meetup. And of course, we want to thank the Iron Yard for this amazing space.
Woo!
Yay! And we are always looking for future sponsors. It'd be really nice to get some food every once in a while, or for future projects, we've already gotten a couple. We're going to be getting some support from Microsoft for some free Azure credits, so we will do some fun stuff in the future with mob-based machine learning programs. So it's going to be a whole lot of fun.
We're also always looking for new speakers, so if you have a subject you want to dive into and we're potentially interested in helping us craft a workshop around, bring it to us.
We have March and April. We have 2 speakers lined up. March is going to be creating decision trees and then implementing one using Weka, which is one of the older graphical interfaces for creating pipelines. And April is going to be on time series data. So don't know much more than that, but we have those 2 lined up, starting to look for May and beyond for talks. All right. If you are following along, you can follow along with Python and or R. If you don't know how to get to Python, python.org/downloads is how you can get Python by itself, or you can go to, I think it's anaconda.org, or you can search for Anaconda download. It's one of the large packages, comes pre-compiled with a bunch of scientific libraries out of the box, so you don't have to worry about whether or not your Fortran compiler is up to date on your computer. For this particular setup, we're going to be using Jupyter Notebook. It's .ipynb for the file extension. It's a really easy way to mix Markdown and code snippets. And we're also going to be doing the same thing with RStudio with a .rmd R Markdown file, so we can have a very similar setup. There's a bunch of places to download R. This is one we just arbitrarily chose, but you can search for download R and download it onto your computer. And RStudio is a separate download, and it makes using R a whole heck of a lot easier. So just wanted to cover those. This is going to be available. We'll have the slides and links posted out to this when the meetup is over. But just so, in case you haven't gotten those on your computer already, that's where you can go. And now,
Woohoo!
we're going to try to do some semi-live coding. I say semi-live because most of it's already written, but we're going to be running it live. All right.
What was the Wi-Fi password for Geo, I guess?
Excellent question.
Cape
Canaveral.
Canaveral. Cape
Yes.
Yes.
The 2 C's capitalized. Did everybody get that? Anybody else need Wi-Fi?
One word. No
One
space.
word.
Cape Canaveral. She's capital.
Yes.
DIY guess.
Again. Yeah, I think it needs to be zoomed out just a little bit more on there.
Just try this.
So,
No, it's going on. Now the whole screen's on there. This is the repository. You can search for Orlando MLDS on GitHub, and this is the only thing in there right now. Should be pretty simple. But this has all of the different the data files, including our Markdown and our Jupyter Notebook in there. A couple of other things we need to take out. This requirements.txt has all of the Python requirements, and all of the R requirements are inside of the R Markdown file. So once you get it in, you should just be able to do pip install -r requirements.txt to have all the Python libraries there for you. Just to give you show you quickly what we're using. The only thing that's not listed here is Jupyter, but we're using OpenPyXL for our XML library, Pandas because we're going to be using a lot of reading into data frames, and PyYAML, which is our YAML library. Everything else is a native code component.
Is this Python 2 or Python 3?
I have it written for Python 3, but I don't believe there's anything in there that would require Python, that would require a change to run on Python 2. The Python 2 still has support for the parenthetical print statements. Yeah, so that's not going to be an issue.
To clarify the goal right now, if you are going to follow along, navigate to GitHub, find the Orlando MLDS site. It's posted on the meetup page, so you can find the link there. You're going to go to either that IPyNB, and if you need to set up a file, we'll help you through that. Raise your hand, we'll run over it. Or if you're going to follow in R, open up that RMND file, both named loading data.
Yes. And we're gonna go back and forth between a couple of different entities here, between the Jupyter Notebook, RStudio, and taking a look at the raw data files on GitHub here. So, quickly show how to load up Jupyter Notebook. So Jupyter is a great data science tool. It allows you to share code and comment on it in a more friendly format than just making a ton of code comments. Once you're inside of the Getting Started with Data repo, all you need to do is Jupyter Notebook loading data.ipynb, and running that will start up a mini server on your computer, which goes ahead and opens our Jupyter Notebook. And if you're not familiar with Jupyter, I covered it just a little bit, but you can see here a little more clearly. It allows you to mix Markdown with native code elements and into a bunch of blocks. Each block you can run after you selected it by holding Shift and pressing Enter. I'll go ahead and run the block, and when it's done, it will update this little line over here for the number that the index that you ran it. The first thing we're going to cover is comma-separated values. And this is one of the few file extensions that tells you almost everything you need to know in the name itself. A comma-separated values file has all of the elements of your data separated by commas. And there are a couple of other variations on this. There's TSV. TSV is the most common second version. That's tab-separated values. They all go under the same kind of format of being separated by something, having a different delimiter. Functionally speaking, it's very similar to this. This is just a regular string that we have commas in here. And if we run this, it's just like running split on a string. So we have string 1, string, these are all strings in here. But instead of, we've split all the data on the commas. If your data is already incredibly clean, you can do things like using a list comprehension to cast everything to an integer. So this line we have digits separated by commas. It's already clean, so we can go ahead and cast things to an int. And that's fine, just kind of showing the mechanics. But for large data files, unless you know everything looks like this, you're probably not going to be doing that. So inside of the standard library for Python is the CSV module, and it has a couple of useful things in there. The two that you're going to be using the most often for reading data in there is csv.reader and csv.dictReader. They operate a little bit differently, but they both operate as generators. A generator is a Python object that only reads in data as necessary. So if you're dealing with a terabyte of data or something ridiculous that's not going to fit in your RAM, really the only way to process data like that is by using generators. So using a generator, you can read in one line at a time, or you can have, say, only 50 lines of data read into RAM at a given time. It's very important to do things like that, especially if you're trying to do a machine learning model that's using up maybe 8 gigabytes of your 12 gigabytes of RAM, 16 gigabytes of RAM. You're not going to be reading in gigabytes of data to train it on. So, I should show you.
1 second, guys. For anybody who's still looking for the GitHub repo or is a little bit behind, I'm going to repost the GitHub page itself to that meetup page so that everybody can get to it. Is anybody like slowing down at that point? It's okay.
I'm taking a second to get our
Okay.
Yeah, we'll get to R in a minute. Yes, so the yes, I do need plus. Yeah, go ahead and do that, please. Yeah, so again, here's the repository. I want to showcase our data file for tonight. We're looking at about 1,500 volcanic eruptions that have occurred in the last 10,000 years. And this is on Kaggle. A link to the original resource is in the README. Well, GitHub does its best to interpret certain data files. So this is it printing up our CSV. But just to give you an idea of what the data is in here is like, we have a particular volcano's name, its origin, its region, the type, so caldera, how it was observed, so either eruption was observed, or for much older ones, you can date it or just have credible evidence, and its last known eruption, latitude, longitude, elevation, and rock types. Now, if we look at this in raw, we'll see why it's called comma-separated values. Our first row up here are all of our column names, but everything after that, well, everything including that, is we have a column and then a comma. One of the advantages of CSV is that it is one of the lowest overhead and smallest file sizes for storing large amounts of data, especially structured data like this. Now, there are a couple of other things that make you want to. Let's go back to Python here. Oh, there it is. One of the reasons why you might want to use a CSV reader or some kind of CSV parsing library of some kind is that what if you have a string inside of your file that has a comma in it? Yep. You have some other kind of reserved character. Usually it's quotation marks. And it will interpret that anything inside this quotation marks is a literal string. You should read it in and ignore any commas inside of it. So there are reasons why you'd want to use these libraries, especially going further into this. You're not going to want to read in raw Excel files. That's insane. Anyway, so this is me just pulling out a couple of generator syntax here, these .next. If you don't know a little bit about Python, next is called whenever you use a for loop. So it's little inner workings in Python. This is me saying for row in CSV data, get the two things and then exit the loop. I'm just shorthanding it here, and you can see the row data. The output of this is our row. In this case, is our header row, and everything coming out of here is a string. The CSV library itself doesn't really do anything to interpret the values. You have to do that yourself, unless you want to choose something that's a little bit more advanced, like we'll see in Pandas in just a second. And the second row is our second row, which is our first row of actual data.
Well, I have a question back here.
What's next called?
Oh, next. So next, this is a function that generators are required to have so that they can work inside of for loops, like you see down here. So for row in CSV dict data.
So all the libraries, the majority of libraries in Python have the next.
Not all. In fact, I say most don't. It's any object that is designed to be used in a for loop. So a generator is going to, a list is going to, or anything that you implement yourself that you want to be iterable is going to have a next of some kind. Yeah, this is a little quick dive into deeper Python. So these just spit out raw row values, separated by our delimiter, which in this case is a comma, and this particular file doesn't have any of the quote characters, but if you had commas inside of strings, it would pull that out as well. I prefer using dict reader myself because it's similar to CSV, it parses it, but if you see for row in CSV dict data, we're going to print out the raw row value. Up here, it was a list of strings, but here is an ordered dictionary, which is a special type from the collections module that actually is a list of ordered tuples where this first one here, the first element is the column name, and the second is the value. But you can go ahead and address it just like any old dictionary. It's a special type of dictionary, and if we were to say cast this to, let's say, to a dictionary, it'll go ahead. It can do that. Oh, didn't run this up here. I'm getting ahead of myself. There. So prints out an ordered dict, which is a list of ordered tuples. We're able to access the information just like we normally would in a dictionary. So using dict reader, we can treat it as though we're reading in dictionaries and access the row values by their column name. And then just to kind of further show this, if we cast to a dict, here's our dictionary, and dictionary that we are familiar looking at with all the same information.
Is it okay if we ask some more advanced
Oh yeah.
questions?
Yeah.
Can you speak a little bit to the mutability and immutability of tuples and lists? Because you seem to know.
Okay. So
Does that even apply in this case at all?
well, it doesn't really apply in this case because you're not accessing the tuples directly inside of an ordered dictionary. If I didn't print this row at all, functionally it's just reading a dictionary. An ordered dictionary is just one that's special where if we wanted to, we could do row.values and then look up the values by index, and it would retain the same order as the headers are in the file. So if we wanted to loop through a CSV by column index instead of column name, using this library would allow you to do that still. All right. So, all right, and now we're going into pandas. Now, for the Python file, we're going to show you a way to read it in using a normal Python or raw Python, and we're going to show you how to read it into pandas because a lot of data science is done using pandas. If you're not familiar with pandas, it's amazing. It's a library that's all about creating tools around two-dimensional arrays. Think an Excel spreadsheet. And it just so happens that the structure of a CSV perfectly matches the structure of a pandas data frame. So they have a very quick and easy pd.readCSV. We give it a file object, and what do you know? We've already pre-populated all of it. So if you don't need to use pandas, especially if you're just doing some very quick analysis or some quick data importing, you can use the standard CSV library. Also, if you're in a situation where you can't use outside dependencies, CSV is still available to you. But if you need to just make it quick and simple, Pandas is, for the most part, going to be able to do that for you. And this is going to be kind of the structure for all the pandas. We're going to save out to a pandas data frame here after reading it in, and then just print the first 5 rows starting in index 0. We can go through, and Jupyter Notebook does a really good job at rendering these instead of printing out some much not less good looking syntax. But this is all the same data. It's just now that we can use it and we can query it and get some summary statistics out of it. In just a second. So the next bit, I want to come over here to RStudio.
Who has seen RStudio before? Awesome.
Okay.
So RStudio in general is an IDE.
Yes. RStudio is a purpose-built IDE for the R language, and it makes using R a whole heck of a lot easier with all the different panes that it gives you. We're mostly just going to be able to run things inside of this R markdown file here on the left-hand side. So I already have all these installed, but I need to set my current working directory here first. No, that was a dumb thing to do. Let's just do this. There we go. That's just saying the directory because R doesn't quite know where it is. All right, similar data structure, and similar to Pandas. Also, if you're not familiar, Pandas is actually a port of data frames from the R language. So a lot of things are going to be familiar between the Pandas implementation and the data frames here in R because they were built after each other.
Pandas
Yes, yeah. Pandas was built off of our data frames. Yeah. So, just like Pandas, R has a very simple way to get CSV data into data frames. Just read.csv. You give it the file path, and we'll run it through head, which will print out the first 5 rows, first 6 rows.
I especially like RStudio because it has a very clear output for reading data specifically. Like it'll have that syntax and you can interact with it the same way you would with a Pandas data frame, but you get that nice and pretty kind of clear. It's much easier to wrap your mind around quickly and get that information out quickly.
Does it have to plug in RStudio?
Huh?
This is an RMND file, which is basically a markdown file which is just like the Python, the Jupyter notebooks. Operates
Yes.
the same way.
And just as we're starting here, I can show you one of the really nice things. In this pane over here, we can go ahead and inspect all of the different data frames that are going to pop into our memory. So if you're not quite sure what's going on, well, type. I can look in here and say, well, it's a categorical variable, a factor, and there are 33 different elements inside of here. So it makes using R much easier. Anyway, that's really it for CSVs. R makes it really easy. Pandas, you can in Python you can use Pandas if you want to do that, or there's the native CSV module. The next thing we're going to look at is Excel. I'm going to switch back over to Python for this one and let Casey come talk about that because she's been living in it for the last 6 months and is very sick of them.
It's not so bad, especially once you find your way around. So Excel is its own. Sometimes you kind of like fudge it and like maybe read it into CSV, but it throws a lot of errors. So
it's a little wonky to work with because it has so many layers of abstraction, so many layers of formatting that can mean something and that you want to preserve or transfer or something like that. Python itself needs a library called OpenPixel to interact with an Excel file. That kind of looks like this. The idea of an Excel file is that you first open the book and then you need to get at the sheets inside. And then you can get to the cells inside and do some sort of process. Working with OpenPixel, it's kind of roughly equivalent to like opening the book because you can reference by those cell names. As you can see here, sit down so I can drive here. So you would go through, and for more information, the problem of Excel has been solved in a lot of different ways with a lot of different levels of effect and appropriateness depending on what you need. You got a lot of options, but this is just one of the better known ones. So you would go ahead and through Open Workbook, that just creates a generator to read the file. We're making a file in this case. You can do both read and write. You go through, save it out, and then you could load it in. Now this process would be the same whether you had generated the file or whether you were loading a file that you were given by someone else. So that would look like load workbook. We have it set to this file path. This is one of the ones, the data loads, that it looks for a path file rather than a specific data set. You couldn't pass in, say, a dictionary and expect it to know what to do. You couldn't pass in even the workbook object saved and expect it to know what to do. You would need to pass it where it is located. And then the interesting thing about OpenPixel is that once it's in there, you do have to do this kind of nested digging and digging and digging past those layers. So if you wanted all the sheets in your set, you'd have to go through for sheet in data. And then if you wanted all the rows in your sheet, you'd have to go row in sheet. So I can print this out, and it looks like this. I have only that one row right here. So yeah, so that is OpenPixel. A little bit wonky, a little bit takes some getting used to. There's some really cool things you can do in OpenPixel and in XLRD, which is to kind of write out those, you can write functions to identify certain things and different objects and then print out formatting. So you could like auto-generate this beautiful Excel sheet, as beautiful as Excel gets anyway. That could be very human interactable. So a lot of different things you can do with it. Pandas is my personal preference to working with an Excel sheet, and this is a really good example of how many different ways you can specify you are loading a file or a data set. So the syntax itself is fairly simple. You have your file path. Again, can't load a generic just like data frame as an Excel sheet. It has to be a file path. But once you've done that, the actual syntax is very similar, fairly similar. Pandas also struggled, the creators of Pandas also struggled with Excel files, so they actually have two different ways of loading in an Excel file at this time. Read Excel is kind of the more comprehensive one. It has more different little moving parts to play with. Excel file is interesting because you can open it up and then kind of the main goal would be to step through those sheets. So you don't have access to as many different fun things, which we'll get to in just a second. Yeah. But it's just a different way of interacting with it. So printing that out. .head in Pandas will always give you the first 10, is it 10 or 5? I can't remember. Let me count. It's 5. So the first 5 rows of your, first 4 rows of your data set and its headers.
The first parameter in that you can specify a different number.
So if I did 10, boop, and now I get awesome. I didn't know you could do that with that. Cool beans. All right, so that's the basic of loading. So oh yeah, what's up?
Specify the rules?
Hmm?
Specify the rules?
Yes, rows of return. So the data set itself could be 1,000,000 rows long, but by calling .head, you won't tax your
No, can you specify in the head which rows you want to see?
Yeah, can you index by rows and head?
That's
No, it's
specifically for getting at the first n number. There's tail, which is getting the n last number, and then there are ways you can specify get subset these rows for different things, but these are specific functions.
How does it deal with sheets in Excel?
Which one?
I mean, if you have multiple sheets, an Excel file.
Good question. So if you use Excel file, you will then have a workbook object, and then you will parse through those sheets by name or by index. That you could specify. I think you can specify all, and it will go through all of them, but you have to be sure to specify, otherwise it will only return the first one. For read Excel, pandas.read Excel, it's a similar circumstance. If you only give it the file path, you will only get that first sheet. But you can't, there are some things you can do to specify all sheets. For example,
Each sheet will have separate data.
yes. Yes, one of the projects that I got more familiar with Excel was I had to concatenate a file with 600 sheets in it into one data frame. It's not as fun as it sounds. The ways that you get those information, and some of them I had to skip a certain number of rows at the top of the file, and just kind of stepping through all of that information, it gets very gnarly very quickly. Pandas is awesome because it's powerful, and it's powerful because it has lots of different option parameters you can pass in for any given function. For all of the read functions, you have 1,000,000 options. You can probably go in and choose just the first 10 rows, skip the last 9 rows, only select these columns, only select columns that rhyme with X, only, there's 1,000,000 different ways to kind of navigate that. Yes?
Question about pandas. I don't know if anybody will know the answer. I know I work a lot with R, and primarily with R. And the way the R system works is, as a language, data frames are loaded into memory, and then everything.
Speak louder, please.
I'm sorry. Data frames are loaded into memory, and anything you do is basically hitting your system memory. So for medium to large size data, R gets to be a difficult thing to work with sometimes. Does pandas work the same way? If you don't know, it's okay.
I do, so I'm not sure that it's pandas specifically. I think pandas is okay, but it depends on the file type. For instance, I had another large file compressing when I was trying to put out to Excel. I switched to pipe delimited because it was much faster to output. I'm not sure if that I'm not sure if that speed is inherent to Python pandas. Do you know?
I haven't done anything specific to pandas itself to work with much larger data sets. I have worked a little bit with Jupyter Notebooks on Azure, and the way that you do it on there is you just add more kernels in the back to handle it.
Are you asking about memory overhead?
Yeah, basically, yeah. In pandas, is it the same? Is it going to use as much as R or not?
What are you considering like medium to large? Like million is medium. Many rows?
Well, yeah, 1,000,000 plus would be medium, yeah, somewhere in there. And that's not bad. Most servers can take that, but as it gets bigger, you have to be more and more careful with R. And there's certain techniques you can use, but you have to be careful.
Let's say a million. What would be a lot of time? Like 1 or 2 seconds?
Well, I mean, a laptop will do 1,000,000.
It's like what Flo said, as long as you fit in your memory.
Right.
If it
And
fits
well,
on
when
disk,
you're working with like your server, like if you have a large server, however many gigs of RAM, whatever, but from your server administrator might not want you, running jobs that are going to kill his machine because he's probably got concurrent jobs going on and everything else.
I just went to a meetup like 2 nights ago for Apache Hadoop and Hive and HBase. It's like handling huge amounts, 300 terabytes of data and serving it over the web. So you might want to look at Hadoop because Hadoop is real heavyweight file system to handle.
lots of data.
Potential future topic if anyone wants to give a talk on how to handle very, very large data sets.
Ah.
I'll have your computer solve that.
To answer the question, I think it would be comparable, maybe a little bit less, but don't quote me on that.
Okay.
And that's totally off
They
of.
behave much the same.
Anyway, pandas. It has a lot of import parameters. So you can specify a specific sheet name, and that can be a string if you know the exact name of the sheets you want. You can pass in a list of those. You can pass in by index number, so you can say I want 0 to 5, or I can say 5 to 10, something like that. Or if you want to get all of them, you'd specify sheet name equals 0 right here. And that would actually give you a wrapped dictionary, and then those dictionary objects would be by sheet, and then by headers, and then by cells. Does that make sense? Gotcha. Okay. Yeah. So, okay, cool. So a header actually works the same way. If you specify that your data set does not have a header, interestingly enough, it will give you that same response as the entire data set wrapped in one big dictionary. And that's useful, especially if your headers aren't guaranteed to be at your header index as well. That's really cool to kind of step through and much more clearly define, okay, for this sheet, I'm not going to want these 3 rows before the header. For the next sheet, I only want, the bottom 10, and that gives you a lot more control over where you are in the file to kind of parse through. And if you're dealing with human-generated data, which a lot of times you are in Excel, that can be really useful. So, and yeah, like I mentioned, you can actually skip rows or columns and select based on name, and that would just be names.column. So yeah, there are about 20 other parameters for loads for pandas that I didn't cover here. So just explore as you need. So yeah, which brings us to JSON. I get to keep talking. Okay. JSON is a lot cleaner than a text file. It can be in a text file, or it can be in just kind of general program memory. It looks like a dictionary because it essentially is a dictionary. And the fun thing about JSON is that you can dump it into a file and pass it around and save it for a later investigation really quickly and easily. And then you load it in Python just as simply. So to print out your data, you would say json.dumps, and then you would have json.load that open file type. See?
Does dump just do printing of a JSON file, or does dump have another meaning?
I think I always get confused. It either JSONifies the dictionary, or it specifically prints to a location.
Well, you see this dump as, load as API in a couple of these different parsing libraries. You're going to see at least in the JSON one and the YAML for Python. When there's an S on the end, it either takes in or puts out a string that you can either send out to a file yourself or send in an API call for a web server. Dump and load take or return file objects. So load is going to load, open, half the JSON file is going to return an object that is of that parsed JSON file. And dump is going to take an object and an existing object and a file object, and as long as it is compatible, which means as far as Python is concerned, only contains basic variable types, it will send it out to the file object and write it. Whereas dump-s here takes in a Python dictionary and outputs a string, or you can go the other way. Load-s will take in that string and output that Python object.
So JSON is nice and straightforward. It appears like a native Python dictionary, so it's very easy to interact with. Same thing for pandas. Obviously, there's a million different things you can specify in your header if you have exact needs, but it's also very easy to use. A cool note on pandas, JSON and dictionaries. If you have an object that basically is a dictionary, you can pass it in directly to data frame and create your data frame right from your program. You don't need to go through these extra steps to kind of loop around. Which can be very useful if you want to do any kind of processing before you enter it into your data frame and do some work on it. So, yep. We have JSON for R. Okay.
Yeah. There's also, I can go over the
Oh,
code
did you?
for Excel and R. Yeah.
Okay. I'm going to back up a little bit, guys, just because there is an R way to deal with xlsx. So it looks like that is the same. No, it's not. So read xlsx.
Question before we-
Oh, go for it.
So, to memory usage, I was just curious. The size of the data file CSV is 200 kilobytes, and if you use info function on a data frame, when you use JSON, it's using 150, and when you're using just passing as a CSV, it's using 140. Just trying to figure out, first of all, why is it different? And second of all, why is it smaller than the file itself?
That's interesting. So you ran that on the object, the CSV object?
I mean, you can see the CSV object just in a file, or like in a browser, and the size of it 250 kilobyte. When you pass it to data frame says I'm using 150 of memory kilobytes. And depending on whether you're passing through JSON or CSV file, using different memory size.
I think I can definitely answer one of that. One of the reasons why it would be smaller in this case is that integers take up less memory than strings, and a good chunk of the data in there. Well, some of the data in the file are integers, and so Pandas does a really good job of interpreting data. So if everything in a row is an integer or a float, it's going to say it's going to convert everything to an integer or a float, and it's going to save you some space in memory that way.
So first parsing every single row and then figure out the type.
Yeah, Pandas does a lot of work for you.
A data frame is made up of something called a series, which is you can specify, if you create a series, you can specify like the kind of data going in, you can specify the column and all this different thing. It will process that for all of your rows as it's generating that data frame from the data you loaded from that JSON. So there's a lot of processing overhead, but it tends to be useful when there's so much to be gained by not having to go through by hand and figure out, okay, can I condense this at all? How can I speed this up a little bit? Where can I cut a couple megabytes? Pandas has been optimized very well for that, and I think that's a reason why it has so many different like parameters and ways to kind of skip around, is because it can't predict all of your needs, but it can provide for a lot of them. So.
But the same if you want to load a big data frame, so a big file, it will take huge overhead to load it.
I can see where you're going with that. Yeah, so just kind of like it would be with anything else.
As you said, the generators just do line by line.
Yeah. I'm trying to think. I think it's if you're interested in Big O, I think it's n log n for Pandas import, but most programmers don't care about that.
Way to alienate a member, Michael. Is that close-ish to an answer? Okay. Cool. All right. Excel in R looks very similar. The module you're using is ReadXL. It's aptly named. You assign your data to a variable, ReadXL, at file type.
There are a couple. There's another library that's a little bit heavier duty called xlsx. I wonder where they got the name from. And it does more than ReadXL, but it has a couple of it has a big dependency on a library called RJava, and for whatever reason, I couldn't get it to work. So in the interest of having working code, I went with our Excel, or read Excel.
They have an open xlsx library as well.
Yeah. Just like in Python, there's tons of libraries for Excel because it's like
Wonky.
having data formats. There are tons of data formats. We need to have one. Now there's a ton plus one data formats.
The one that she mentioned doesn't use the Java backend either, which is really nice. Yeah.
See, I can't use, I use Windows, and so I can't use the open xlsx on mine. I have to use the xlsx on mine.
Would you prefer to use the OpenXLS?
I don't know because I don't know the difference. I can't even get it to work at all on my machine. So I use the xlsx, and it does what I need it to do. So
Okay.
I mean, I'm good with it.
What's your use case?
I actually work a lot in Excel. I program Excel. I have a.
Hi.
I love Excel. I do filters, all kinds of stuff.
That's really cool.
VBA, and VBA actually looks a lot like RStudio. It has the separate windows. If you've ever been into VBA, it has the same exact 4 windows.
I
But
tried to do VBA, and that's what brought me back to Python and Pandas and dealing with Excel sheets through Pandas.
yeah, I do. I work a lot in Excel. That's my tool of choice. But I'm learning R. I'm working in R a lot, and like I said, the XLSX, I can bring in specific sheets, whatever sheets I want into R. I can bring in a cell if I want to just specify one cell. So it's really powerful if you want to bring in anything from Excel. You can pinpoint a range of cells, anything you want in there to bring in.
That's awesome. Cool. I could have used you on my last project.
I have to give you my information.
When creating these files, the preference was, is there a native component? What's the most popular library? And then what worked? This is the one case where it went with, well, what works. So, but whenever you're programming, the best library to use is whichever one works for you.
Surprise, you can also load JSON in R. The command here is from JSON. And again, that's that location.
And this is using a third-party library because R doesn't have native JSON support.
Yep.
So this is using JSON Lite. There's another JSON library that I was looking at before, about as popular, but very similar syntax between the two.
I know a guy who's trying to use R to parse something, and it seems like a terrible idea.
That seems like a terrible idea.
And so, do you know of any libraries that could assist him other than use Python to pre-process it?
dplyr and
tidyr.
Yeah, dplyr and tidyr.
That's got everything you need. If it's that's the one.
Those are the go-to. R is going to be fairly simple, except with one exception down there, because I'll give you a hint. I didn't get one of these to work in R.
All right.
But the next one is going to be XML.
Let's skip that
one. I'm going to cover it briefly, because we can go back to the Python one.
Gotcha.
XML has historical importance because there's a lot of data that if it hasn't been touched in a while, it's probably an XML format. Or if you're dealing with, say, government-funded APIs, it's almost always going to be an XML if they haven't been touched in years. And XML itself has a lot of overhead, but almost everyone in here will be able to read it because it looks just like HTML. Let's go to the GitHub page and pull up the XML file.
Oh, that was it?
Yeah, just go back to.
Is this the right time?
Yeah, go back one more.
Sure.
Come on, too far back.
Okay. There's our page, by the way.
Oh, just go into data.
Okay.
On the link here.
Oh, gotcha.
Perfect. So, to give you a little background info, I downloaded the CSV for this data set and used Python or Excel itself to convert into the different data types. This is the only one that didn't really want to play very well. So to give you an example, rather than not having one at all, this is a single entry from the volcanoes data set.
Single record.
This is a single record, and it does look a whole lot like HTML. I don't remember. I'm not sure the historical context, but I'm sure there's a lot of cross pollination there. But column name at the very beginning, just like br dot, just like you see in HTML. Attributes that are key value pairs, the value inside, and then a closing bracket. And we can go into Python.
That's not Python. This is Python.
Yeah, it's Python. So, XML, extensible markup language. It is older, and thankfully it is being superseded by other web frameworks, specifically JSON, and to a much lesser extent, YAML. You'll still see CSV, Excel, and JSON as the most common data types out there. This is showing you the element tree. This is another. This is a native Python library for when you need to go through XML, but it's not that great. So etree.parse, we open the file, we get the root node, and then we can iterate through the different elements by getting out the tag and then the text. There's also item.attributes to get the keyword pairs. There's really not that much to say, and there's also no good way to do it in pandas either. Surprise, surprise. There are some ways out there that if you really need to, you can. People have posted functions to get the job done for you. It usually involves doing their own kind of parsing using etree or native string parsing, or converting it into some other data type and then loading it into pandas. There's not a good way to do it other than that.
XML will often have like tree structured data, or at least several layers. So can pandas and R only work with like rectangular data? Can we have a cell in which there's multi?
I think it would put up a fit if in the tree it was missing a column value.
So it'd have to be 2D, basically.
Yeah, you'd have to try to implement a 2D array into the tree structure. It's just XML is not meant for data frames at all. I think I saw a hand or two. No, okay. On the R side, I think there was. I was just trying to pull out that single element. Yeah, the single element XML file. This is using the XML library, XML2 data frame. In theory, this would work. It's just there's no good way to do it in Python with pandas.
So if you need to parse XML, bring it over here and save it out of something else.
Then, now that we've somewhat skipped over XML, YAML. YAML is probably the newest one of the different data types that we're showing off here. YAML is yet another markup language. It's almost an inside joke for the 1,000,000+1 frameworks. YAML, fun fact, YAML can parse JSON files because they're very similar. YAML has a little bit less overhead. Bring up the YAML file. Yeah, it has less overhead, and unless told otherwise, infers that everything is meant to be a string. So unlike JSON, where everything's inferred to be either an integer or integer, float, or pretty much anything that's not a string, YAML goes ahead and says, we think everything is a string, and unless otherwise told, this is how it is. There are one of the unique things about YAML, especially if you are looking for how to reduce the storage size of large complex data sets, YAML can do internal referencing. So if you create an object that is referenced inside of other objects, most data format types, you'd have to copy the data. YAML allows you to do object indexing to save, in some situations, a considerable amount of data or storage size. I don't have an example. Sure, you can look one up. I know it exists, but I haven't used it personally. YAML itself, you can find it on the web sometimes, but it is you're most often going to run into YAML files for local configuration in applications. So that's where it has found its home, and that's where it is right now. But for large things, that self-referencing, once it gets implemented just a little bit more, or more people know about it, you could see a lot more YAML data sets out there.
It's in a nice sweet spot between machine readable and computer readable.
Yes.
A human can sit out and just type stuff and make sense in a structured format, and it's probably good YAML.
YAML, a human written YAML file looks like JSON minus all of the brackets and colons and curly braces. It looks like you're just typing code. It's it's the Python of data formats, because white spaces can be significant.
It is.
So there isn't a YAML library inside of the standard Python, but there is a library called PyYAML. Is arguably one of the most popular. There's another one that's built on top of it that allows for a little more, takes care of some edge cases. And this is one of those Python libraries where they'll call a package one thing and then you import it as something else, which can be a little confusing. But it's in the requirements.txt file. So just the same thing that we were doing with Python. YAML also conforms to load, loadS, dump, dumpS protocol. So if you know how to use JSON, it's really easy to use YAML as well. Then pandas, we're actually going. There's no native way to read YAML in, but we can use. We can hack the JSON component of reading in pandas data frames to read in YAML files. So it looks a little clunky, but it works. So in RStudio, I will confess, this is the one that I couldn't get working. There's YAML for the third-party library. It has YAML.load file, and it loads it out as a specifically formatted list, like ordered list, marked up list that is supposed to be able to read it.
It's a list of data frames. That's what it's putting out.
That's what it's
At
putting
the
out.
end where you're as data frame, if you change that to as character, it'll put out a list of characters and you can
Here's some live coding, guys.
no S, just character.
As
As character X.
So go ahead and uncomment those two, and let's see.
You don't. Forgot R doesn't have the quick, nice.
Not that one. Not that.
Oh.
Unless you want it not to
You need
Just
to
see
put
if
that-
y'all were
you need to
awake.
put, open
Parentheses
close
X
paren
after
X.
character.
Yeah.
Oh wait, what?
as character
As character parentheses X.
Oh.
Yeah, there you go. Open close X.
X.
X. My bad. Sorry. Hard of hearing. All right.
Live coding.
Da. Woo!
Sorta.
Sorta.
It needs to be unlisted, but yeah.
Nice.
So we've already had one pull request tonight. If you want to make this look like all the other ones, go ahead and make another pull request, and that will certainly help people going down the line. The last thing that we want to touch on, and I'll let Casey talk about this, that both R and Python have mechanisms to export binary versions of language data objects. So in R, it's our data files. In Python, it's called pickle. And if we can save out integers, lists, data frames, your custom classes, whatever you want. It just saves it out as something that, in a binary format, that is able to be read in later as an exact copy.
So yeah, you can use pickle files in Python. So one thing they're particularly useful for, I don't know as much about the history and where pickle came from, so you know that, interrupt me. But one thing pickle is really, yes, it's called pickle. I see you laugh. Is that what you're laughing about? It's called pickle? No, never mind. Sorry. I think it's funny. But one thing that pickle is really nice for is you can actually it's a cheap form of data of kind of data collecting, and if you are working on a model or a data set or a data frame and you're at a certain point and you want to stop, but you'll lose your progress if you let the memory drop what's in memory, it's really nice to be able to just like slap it out to a pickle file and then live it.
So it's a persistent.
Yeah, it's
Yes.
serialized.
Yeah.
Yes, absolutely. I'm not aware of it being used as kind of like an in-production storage mechanism for websites or anything like that.
You can.
I know you
One area where you might actually want to do it in a production setting would be training a machine learning model that you want to run in the back end of a website. You could just save it out as a pickle, and then when your website gets an API call, it just imports the pickle again. You have an exact version of the model that you trained, run the data through it, and then you have a persistent machine learning model ready to go.
Yeah, which is really, really helpful if you've been working on the same model for like 9 hours and you need to sleep finally. So yeah, it's just one of those cool tricks to, yes, in the back.
When you say it's a model, what is that?
So in Python, you're working with everything as an object, and any kind of statistical model or machine learning model is an object itself. You can save that model out in its current state. So you can have the model as you've trained it so far. Or if you have a certain number of parameters or something, you like this model, but maybe you want to go in a little bit of a different direction and you're switching files or computers or something like that, you can... What is a model?
When you say model, does that mean like is it an array?
No.
Stuff, or
It
a
is...
matrix, or
It is an object. It is...
Well, when
That's
we
a
say
big
model
question.
here, it's just a machine learning model. So you train it on some data, and then you can give it something else, and it will predict out a value.
you can actually just say that whole thing.
Yes, and that is awesome.
Yeah, is to put it very bluntly for both pickle and our data, and most languages have something akin to this. Anything that you can assign as the value to a variable can be saved out in one of these files. It's absolutely anything
Including
you
like
want.
functions you've written.
Yeah.
Yeah.
You can
Like,
make save and
an array
store
of
a
all
function.
of everything you've done so far, and just dump it out the disk.
Yep.
Reboot your computer, come back later, delete it all back.
You can export you can save third-party libraries. So if you import, say, CSV, and then you extend the CSV module, you can export the module out as a pickle.
It's like a digital version of a thumb drive, almost.
So
That's how I
I
think of
didn't
it.
have to install all those libraries like pandas or anything. You could have just added it to the what do you call this? The Git repository.
I know what you're getting at, but I think even Pickle will complain if you try to load in a data frame and Pandas is not imported yet.
Okay.
Yeah, so it still needs to be there, but as long as it can run, it's just like having a checkpoint in your file.
Yeah.
Thank you.
That was, using it in that way was one of my favorite things learning. It's like, you can do that. That makes life so much easier. So I always get excited when I get to share that. So yeah.
And there's a way to do it with Pandas.
reading pickles is very simple. The nice thing about pickle is that it doesn't make you think too much about how it's formatted, whether it's like split by commas or pipes, or like how many nested layers are you going to have to wade through, or sheets or anything like that. It just gives you what you want, and there's beauty to that. So.
Yes, there is.
Oh, I didn't. Did I not run the? So that's run.
There's no pickle file in the repository.
Yeah, it just
Here it
didn't
is.
run- it just
I ran
didn't
it
run
out of
the first
order.
one.
Fun fact about Jupyter: if you run a code block that is below another code block without running the top one, it will act as though that one does not exist. That is not a continuous file, like you can run the whole file and it'll go top to bottom. You actually need to run the code blocks in order or run them all to get those variables to transfer one to one to one. If you do run a block like way up here and say I'm loading for some reason the pickle load right up here, and then I skip all this in the middle and then do this, it will still work. It will still have that memory of that pickle load, but you have to have loaded that pickle or whatever module you're loading before using it. So,
The more you say it, the more funny pickle gets.
pickle.
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 And also, data frames have a function there to pickle. So if you you don't have to import pickle, it just has a function there for you.
Yep.
And I guess before we go to the R file, I included on the bottom how I the only one that's not in here is CSV. CSV to Excel, but I just used the Excel program to do that. This is how I changed the CSV file into JSON, the single XML, and the YAML file, in case anyone needs to see it. The only thing that you're not going to be able to run there is dict to XML, which is a third-party file that I found and use a ton.
All right, same thing in R. As we are dealing with statistical analyses, we will have models. You have a way to store these models and persist these things across time. In here, that's called an RDA, or is it?
It's an R data file. That click this guy right here.
Oh, okay.
That'll move it up on the screen a little bit.
There you go.
And then you can scroll.
Cool. Okay. All right. So, boop.
R just makes it really easy. It's already native. It's load save.
Yep.
Very simple.
I have a question.
Yep.
If I wanted to stream data from like one software, and eventually I want to publish it to like, a Wi-Fi server or like I have a router and I want to publish it like digitally, but I also want to have access to it after I stop running it. So I want to be able to say, you know, all the data that I want to be able to grab all the data that I was streaming like 3 days ago. Would a pickle be used for that? Or would that be like?
I think you're looking for more just a data log.
Yeah.
Yeah. There, you might be interested in. You can craft CSV files. The kind of thing that I do in production is I'll have a set CSV file, and starting in Python 3, they amended the print statement so that you can use the print statement to write out to file objects. I can quickly show this on here in case people are interested in it. Let me add below without running that. Just make this big so everyone can see. So let's say I just have some data in here, and this is all of the log data that is getting sent out over my connection. Before I send it out, I can do print data file equals open, my log.log in append mode.
Right.
And this is going to say, or actually, to make this let's say data if I really want to do this the proper way, I can do actually, let me just go ahead and separate this out so you can see this. Yay, live programming. So, oh, that's what? Oh yeah. So let me comment this out just before I run it. So I have an array or a Python list of data that I want to save out. I can fashion a line by converting everything in here to a string and then joining it using commas. Now they're comma separated. Aha.
Unless there's a comment inside.
Unless there's a comma inside it, but I know going ahead that everything inside is an integer, so I'm good. Or there's a csv.writer or csv.dictWriter if you want to take care of that as well, and then sending things out using append. So that turns that dictionary into a CSV compatible row of integer values. And then just run this again. Now I've printed it to a file in append mode, and I can run this a couple times. And if we go into the, I don't want to go into the repository down here, mylog.log. Oh, VS Code isn't in there. Text edit, whatever. There it is. And there are ways that you can get around that you can make it a little more circular, so you don't have infinitely large log files. Like only keep the most recent 3,000 entries.
Oh, okay.
Or there are ways to handle that, but just getting the data out in a log file is probably what you're looking for.
Yeah. Well, actually getting into it, I'm trying to figure out.
Yeah, and then you can use the things you've learned here to read the data back out.
Can you go back to yeah.
We can save that as an example and push it to the GitHub repo.
It's like my first time streaming things via Wi-Fi, so I'm like, okay, is it gonna be lost forever, or is it like,
Oh, and just to remind everyone, we're live streaming this right now, and it's going to be available. It's going to be archived on our YouTube page, so this will all be up there as well. That is all we have tonight. Covered CSV, Excel, JSON, XML, YAML, and then pickle in our data.
We really wanted to do this one specifically because it seems like a lot of times the biggest hurdle to getting into data is like getting at your data. And once you get in there, we didn't want that to be a barrier. We wanted to provide a resource to kind of like help through with that first step. Because it's so much fun to play with data. Nobody should be barred from it. Everyone should have the tools they need. So we wanted to make something, and if you guys have any feedback on making it better or how we could have made this clearer or additions, or maybe you know of a data type or a file type that we didn't cover, submit a pull request to the GitHub repo, send it our way, Slack us, all that fun stuff. So, thank you, guys.
While we are still running the stream, are there any more questions, either on this, about this group in general?
It's my first time here at Udemy, and
welcome.
I'm deeply interested in knowing about it, but I have no idea where to start.
Well,
Sarah.
actually, to plug to plug a different meetup of mine, I also run Orlando Python, and our December 5th meetup, we live streamed and recorded a bunch of 2 PhD students who gave a talk on Keras, the basics of neural networks and a quick implementation in Keras with Python, and that's available in the. I think that's on my channel. I'll post the link to that in the meetup comment, so you can get a link out to that. Watch that. They did a great job talking all about neural networks.
All right, perfect. Thank you.
And if anybody loves neural nets and wants to give a talk about that, let us know.
Yes, there are so many things that we can talk about.
What's the R meetup called?
Hmm?
What's your R meetup called?
Oh, we don't. Not an R meetup. It's the Python meetup.
Sorry.
Yeah, Python meetup. It's the Orlando Python user group, OPUG.
Oh, pugs.
I like it.
So, if that is it, we will see everyone.
I got a quick question.
Oh,
In terms of machine learning, is anyone interested in very particular topics aside from, neural networks?
Autonomous cars.
That's
Yeah.
Oh yeah, not necessarily machine learning, right?
Yeah.
Definitely.
Well,
It's all.
Machine
neural networks.
meaning like topics in machine learning. That's an application. Oh yeah, autonomous quadrilateral drones in like storm arenas and. So, is anyone interested in like Bayesian predictive methods or predictive type models or something?
Yeah.
It's like exactly right.
yeah. So
Testing against like natural logs and stuff like that. It's always interesting.
yeah, we're looking for general topics, language skills like this, and creating the visualizations from the previous meetup. If you have we've done lightning talks at previous meetups, some in the meetup community, and that would be a good one if for self-driving cars. If there's anything that people have been working on that really want to share, you get maybe 6 people talking for 15 minutes about something they're super passionate about, and that's another favorite.
Was that a question over here?
Oh, I was just going to say, these topics of like Spark and Apple or like scalar and stuff like that.
But I imagine everyone would want to see code, right?
Yeah.
Code is always nice.
Yes, we love seeing code. As much as we love the gigantic presentations that are really thought out and have pretty pictures, sometimes you just kind of want to see, well, how in the world would I implement that myself? So having a nice balance of those two are usually the most effective.
To answer that question, we will definitely cover scikit-learn in the future.
Yes. I actually led a workshop back in September at Orlando Python as well on sklearn. That's GitHub/Orlando Python, and I think it's there under ML Workshop. You can find some stuff under that if you're interested. Anyone who wants to give a talk at this group about scikit-learn can either make their own or start there to think of some ideas.
Dude, you're like the whiz.
This was fabulous. I'm glad I came. Thank you.
All right, and I hope everyone comes out to the next one, which is going to be on decision trees and Weka. So until then, we will see you all and hope to see you in the Data Science channel in ODEV Slack.
What is Weka?
As it was described to me and as I saw, it looks like the ancestor of the Azure ML visual pipelining suite.
Ancestor or descendant?
Ancestor.
How's
It's
it spelled?
older. WEKA, I believe.
If you ever buy the
Weka.
I know. That's what I thought they were.
but it's all like completely in Weka. So just be careful, like when you buy, the buying books. You might be working on ancient stuff.
Right.
Who did we talk to get on the other Slack?
You can talk to any of us. I think about at least half the people here I know are on ODEVs or I've seen at other meetups. So
Anyone who is on the ODEV Slack can do /request invite email All they need from you is your email. You will get an email from Slack, and they will be like, "Hey, do you want to join this?" You'll be like, "Yes, I want to join this."
As long as you're not a recruiter.
As long as you're not a recruiter. And then you specify your username, you put a password in, and then you join. The Slack you're looking for will be the ODev Slack. We are a channel within that kind of umbrella Slack channel. So don't be confused when you say, "But I thought I went to machine learning, not ODevs." Same thing.
Confusing enough, there's also an ODev's meetup tomorrow night, which is people who are on the Slack. So it's upstairs.
Oh! I have an announcement, speaking of that. The Orlando developers are sending around this lovely salary survey to all of the groups. I will be forwarding that to this one as well. If you are interested in taking that, please do. I actually helped work on it as a data person. It's a very exciting project. It's the first year I was on it, so it's kind of like a new thing, and I'd love feedback and suggestions, and I'd love to see everybody take it.
And I forgot to mention it the last meetup, so I'm definitely going to do it here. Code for Orlando, if you're not familiar, it's civic hackers. We create applications and work with the city to open up some of their data sets. We are putting together a data science team inside of Code for Orlando to work on some data science projects. So if you want a project to work on, or you want to work on something that's going to have some kind of civil impact, do come out there. We typically do our onboarding session yesterday, the first Tuesday of the month, and we're also starting a second meetup during the month over at the Winter Park campus. Meets over at Canvas sometime during the third week of the month. The date still is changing around there, but if you want to be part of that, definitely come out to Code for Orlando first Tuesday of the month. So first Tuesday that's going to be March 2nd.
You have to sell it
or
better
7th.
than that.
He is the data librarian
And
for Code
he's
for
a data
Orlando.
librarian. I'm the delivery lead and the de facto head of the data science group until we can find someone else who wants to take that up.
Government is terrible at attracting tech talent. So we, technical people, we want to improve our city and make it better to live here. And so we do the things that government either doesn't know how to do or doesn't have the intention to do. We don't ask permission. We just go out and fix things, make things awesome.
Rebels of goodness.
Yeah, first Tuesday of the month.
First Tuesday.
You sold it that.
You have to be based in Orlando with you guys?
Nope.
No, you said the city, but county, state, federal, we go any levels to do what we need to do.
I technically don't live in Orlando. We're code for Central Florida for all intents and purposes.
Orlando's in the name, but not Orlando City.
Open up the government.
Any other announcements?
There are ladies here tonight. So Lady Devs next Wednesday, 2 Wednesdays from now. Be there, be square. Yeah, the 22nd. It will be at Teeps, actually. They have their own, it's up in the market. Is it a meetup? Yes. Yeah.
I guess so.
You guys are so patient. You sat through and listened to all of our other pitches for meetups. So nobody was like, well, I'm done with this. So you guys rock. Thank you for your attention.
Thank you everyone for coming out.
What kind of data sets do you guys work with on that project?